Hello everyone, and welcome to the final video of the Line Tracker series. In this video, we're going to go over the loop section, and by the end of this video, you should have a fully functioning, competition-ready line tracking vehicle. The loop. This is the heart of the code, where the direction that the car moves gets determined based on which sensor is above the black line. Inside the curly braces of the loop section, let's begin writing code, starting with the comment saying what should happen if the sensor to the far left is the sensor above the black line. In order for this car to recenter itself above the line, which direction do you think the car should turn? If you said left, you're correct. One more important thing that will help make this video make sense: these sensors are really light detectors. One bulb on the sensor gives off infrared light, and the other bulb is a detector checking to see if any of that light gets reflected back. If no light is reflected back, that means the sensor must be above a dark, non-reflective surface, or in other words, the black line. Anyway, moving back to the code, inside the curly braces of the loop, write a comment saying, if the left sensor detects the line, turn left. Keep in mind, the left sensor communicates with the Arduino through pin 13. You can add that small detail to your comment if you like. Now let's write code to make this happen. To translate the first half of that comment into code, the part that says, if the left sensor detects the line, we'll use an if conditional statement on the next line that gets written like this. If the digital read of pin 13 is equal to low, this is an if conditional statement, which I won't go into much detail about in this video. But to learn more about these and other conditional statements, make sure you watch our video on conditional statements. The digital read function is checking up on the status of pin number 13 on the Arduino to see if it's receiving current from the sensor. And if the digital read is equal to low, that means the sensor connected to that pin must be above the black line, as no light is reflected back to it. Anyway, you said earlier that the car should turn left if the sensor to the left detects the line. To write code to make that happen, move the cursor to the line below, type an open curly brace, then hit enter. You may have noticed another curly brace appeared. It's in between these curly braces that you will type the code to make the car turn left, meaning the left wheels must turn backwards and the right wheels must turn forward. To make the left wheels turn backwards, first leave a comment for what's about to happen. Then on the next line, type digital right, parentheses, 7, comma, high, parentheses, semicolon. Make sure you type it like I did. And on the next line, type digital right, parentheses, 8, comma, low, parentheses, semicolon. These two functions together will make the left wheels turn one direction. If you were to change the low to high and the high to low, that will make these wheels connected to pins 7 and 8 turn in the opposite direction as before. Now let's write code to make the wheels on the right side go forward. Leave yourself a comment. Then on the next lines, type these two lines of code for pins 4 and 3. Next, upload the code. Plug in your Arduino, and then click Tools, go to Port, and make sure that the COM port is selected for your Arduino. And then hit this button pointing to the right to upload the code. Insert your batteries. Hold the car over a black line so that the left sensor is above the line, and check to see which direction the wheels turn. Are the left wheels turning backwards like they should? Are the right ones turning forward like they should? Both of mine are turning the wrong way, moving the car away from the line. I can fix this in the code by changing the highs and lows for pins 7, 8, 4, and 3 to be opposite of what they are. Ah, that's more like it. Now let's write code to make the car go forward if the middle left sensor detects the line. Staying in the curly braces of the loop, but moving out of the curly braces of the condition that makes the car turn left, create a new condition for when the middle left sensor connected to pin 12 detects the line, which should make the car go forward. First, comment what you're about to do. Then, on a new line, create a conditional statement checking to see if the digital read of pin 12 is equal to low. Then hit enter. Open a curly brace and hit enter again. Then in between the new curly braces, begin typing the controls for the motor. Do you think you could figure it out? If so, feel free to pause the video and try. I'm going to copy the lines from above that made the car turn left and paste them in between my new curly braces. Then I'm going to change what the left wheels are doing, making them go forward instead of backwards. Since the right wheels are already going forward, I'm going to leave it just as it is. Upload this code. Move the car to the black line and see what happens. When the left sensor is above the line, the car should be turning left. If the middle left sensor detects the line, the car should start going forward. Now see if you can write code to make the car go forward when the middle right sensor detects the line. And also write code to make the car turn right when the right sensor detects the line. Feel free to pause the video and try yourself. If you want to check your code against mine, here's what I did. Now upload this code, and once you get it right, you can hit the floor now. You ain't gotta wait. Put some tape on the floor and make a line tracker course. Record it and hashtag 4Minute Robotics. It was a lot of fun. Until next time, people, keep coding. If you found this video entertaining or feel that it made learning robotics slightly easier, do me a favor and hit the like button and subscribe to my channel. Thanks for watching. Goodbye.